So for today's project, this is a Bobcat S220 skid steer. I believe it's a 2011. Customer dropped it off. They're having problems with the quick disconnect on the bucket. This is, Bobcat calls it Bobtach, but there's a cylinder here that's used to disconnect the bucket, and it moves the handles in and out. I guess I don't know all the details, but I guess the rod started to bend and it got to the point where it wouldn't even go in and out anymore. So they dropped off the cylinder, and this is what's left of the gland nut. I guess the gland nut got, I believe it got probably, this is aluminum, this is steel. I believe what happened is it just, the threads galled up in it and they couldn't get it out. And they ended up cutting it out, and I think they may have used a lathe to maybe bore the inside of it out. I'm not really sure, but this is what I'm left with here. They also dropped off, this is what's left of the rod right here. I guess they had to cut that off in order to get it out. But what's in order for today is to see if we can fix this thing. Haha. This is what's left of the gland nut. Like I said, I think they cut it off, and but what's left of this is we still have the gland O-ring, but we're missing the rod seal, and there's a wiper seal on the very front of it, and obviously we're missing the threads. So somehow we're gonna have to figure out how to recreate this. And so this is what they dropped off, and obviously we got to make something that looks like this. But I think what they did is they heated up the outside cylinder with some torches, and they were trying to get this part to unscrew from the barrel. Now, what they had was two holes here, and they fit a spanner wrench here, and they tried to use a ratchet to turn it. Obviously it didn't turn. I think what happened is, as I mentioned, that the threads probably got galled up. You know, this is aluminum, the tube is steel, and it just welded itself. So I think they cut it off, and then they went in there with a boring bar, got rid of all this material, and that's how they got the threads out of the tube itself. But this is what we're left with, and how do you go from this to this? So I drew this up in Fusion, and this is kind of what the gland nut. They didn't want the spanner nuts, so they asked if I can make it so it's an actual nut, which that's no big deal. So we added that to them. But how do you go about, like with these O-ring grooves that you need for each one of them? I'm going to use the dust groove for the first one and go into analysis. Like, how do you know how big to make the depth here, and what the diameter should be, and this diameter? Well, I usually go and email Hercules, and they'll say, I'll tell them what my application is. In this case, it's a Bobcat. It's a small cylinder used on the bucket. So they'll say, well, you know, this is probably a good fit for your application. So I'll look it up, and I know that the rod is 1 inch in diameter, which is all I really need. I just need a wiper that's good for a 1 inch rod. So what's happened here is they tell me what these dimensions should be. So if I go look, for example, D, which is the width of the groove, go down here, 0.187. So if I go to my drawing, this should be 0.187. I go here, 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 this face here, 0.187, 0.187. And it also tells you what the diameter should be, which is in this case G. So if I go down to G, 1.372. Go here, just check the diameter, 1.372. So that's how you would go about drawing up one of these when you're starting with basically nothing. And you do the same thing with all the other grooves. This outside groove I actually had from the original, so I was able to take that diameter and just use the original one. But these two inner ones obviously I didn't have because they cut it off when they tried taking it apart. But that's how you would go about figuring out how to make the length width of each one of these grooves so that when you order the seals they'll fit in correctly. As you can see on this, by the time you draw it up and then you got to figure out what seals you need and get all the measurements right and load tools up in the machine and order material if you had to, it's even for me to do this is a couple hours. And when I say client in this case, what I'm really saying is neighbor. And when I say neighbor, that means this is a freebie. So I'm just doing this to help them out. We help each other, they help us, we help them. But this would be tough to make money on this job just because there's so many little pieces, and you can go buy one of these off the shelf, so it really wouldn't make a lot of sense to go and do this. But for this purpose, because it is neighbor, we're just trying to help them out. It's like I said, it's not going to take us too long to do this, but for normal clients, it wouldn't make any sense. Just go buy it and be done with it. So I took some measurements, used that Hercules manual and figured out what the grooves are. Made this hex on the outside because that's what the customer was looking for. And, just took some guesses. It may not be perfect, the first one, but this should get us kind of close to what I think was the original. I like to go through and simulate this before I run it in the machine, so I'll do that now. We'll go here, simulate, and we can just run everything. This is doing the facing operation, some profiling. I'm going to switch tools. This is also doing profile, but I can get really tight with the corners here. This is going with the insert drill, rough boring. This is doing the internal grooves for the seals. Final. This is doing a final bore. This is doing the final external O-ring grooves. This is going to come and do the threads on the outside. And this is doing the finals. This is cutting the outside profile for the hex. This is the final for that. Do another facing just to get rid of any scratch marks that were on the outside. And that just did the final cutoff. All right, we're going to get ready to start machining this, and what I did is I touched off the end of the part with a piece of paper, and now I'm going to tell it that I want to go 30 thousandths in from that piece of paper. So you see me type in 0.03 here, and what I forgot to do is type in teach, because when I go back to the position, that should read 0.03, meaning it's 30 thousandths in from the end of the part. So I gotta go back, type in 0.03 again, but this time type in teach. So now you can see it reads 0.03, meaning the end of the part is now going to be 30 thousandths in from where that tool sits right currently. This is going through and doing the rough boring. For some reason I lost sound on this. The next tool up is, this is doing the internal grooves on the, for the O-rings. So this is doing the front dust seal. You just, overall, you'll notice that there's not a lot of stick out on this particular tool just because it's, I think it's a 1/2 inch tool. You really only allow 3 diameters in terms of length, how much stick out you have. The more you stick the tool out, the more chatter you get. So it works out well to have the part oriented like this, but you'll also see that the way the threads are going to be done, I can't really test fit it, which you'll see it show up in the end of this video. I had to do some extra machining on the end of it in order to make the threads actually work. We can go in that into a little bit of detail later. So the way I had to machine this, the threads were on the inside, so I really couldn't test it in the tube. And I used a 3-wire gauge set and I was right in the middle of the tolerance. Unfortunately, I'm only as good as the mating thread, so I had to cut it down a little bit, and you can see me test fitting it here coming up. Now, I don't want the threads to be too loose, but I also don't want them to be binding. I want them to kind of be kind of hard right up until the end, so then when I put it on there, it's going to be snug. But again, I don't want the reason why this whole thing failed to begin with was because the threads were way too tight and ended up galling on the inside of the, this is really where I want it. I want that O-ring to smash down in there, but again, I want to be able to have it tight without it binding. So the last piece we need to work on is the actual rod itself. I bought a brand new 1-inch rod, but you still need to thread the end of it and add an area for the piston to sit on. So I modeled this up. This is pretty much exactly the way the old one was. It's a big chamfer on the front. This is an M16 by 1.5 thread. I added a thread relief. This is the area where the piston sits, and yeah, that's about it. And we put a chamfer on here just to make it so when the dust seal goes on, it doesn't bugger anything up. I can go ahead and just simulate this quick. Simulate. We run this, does a facing operation, goes through and does the profiling, final profile, thread relief, and that's the threading operation. This is the actual machining portion. I did this on 2-axis Mazak. This is a turret lathe here, but you can see this is going through and doing the profiling. I'll just let this run here. finished product. That's pretty simple for a CNC lathe to do something like this. I just wanted to show this, but I used some double-sided tape just to protect the end of the rod when I was machining it. You can see there all the that's the marks left from when the jaws were clamping down on it. So again, it's just a way to protect the rod so it doesn't get all scratched up and marked up from the jaws. And here we're going through final assembly. So this is the main O-ring that goes in front of the threads. Next is going to be the actual gland O-ring, goes on the end there. For some reason I lost the footage of getting the actual dust seal on. Those are always a bugger to get in because they're just so hard. And this, I think it's even worse because it's smaller. These are small diameter dust seals. It just makes it hard to scrunch it down in there. And here what I'm doing is, after I got it in, I'm just trying to line it all the way in, because again, it's so hard to get those things in there, and they kind of buckle up on you. So I'm just using this piece of wood to stretch everything back in to where it's supposed to be. Here everything's fully assembled, and I dry fitted onto the actual rod. Everything fit pretty good. It's got a good solid fit, but it's not too hard either. Next thing to install is the piston O-ring, and it's actually made up of two. It's got a normal O-ring on the inside, and it's got this glass-filled PTFE O-ring on the outside. That's actually, it's a Teflon. These are a real bugger to install, and I usually try to heat it up first just to make it a little bit easier. And what you see me doing here is I have it in a crock pot. I put some hydraulic oil, I heated it up, I think to about 140 degrees, and just to get it a little bit easier to slide over the actual piston. So here's me installing. I got the O-ring goes on easily, obviously, and then what I'll do is I'll slide it over as best I can with my fingers, and then I'll use a screwdriver just to get it over the final piece of this. Now, what happens with these, even after I use the heat to heat it up, it's still stretched. So what I'm doing here is I use just a hose clamp, and this actually just kind of shrinks it back down to what it should be, normal size. I'm just going through and test fitting the nut after I had the gland nut seal on, just to make sure everything's going to fit okay. Alright, we're going to go in for final assembly here. I had some video footage of me welding this, but for whatever reason I can't find it. So anyway, I just cut the old one off, and this is the eye from the original. Just welded it onto the new rod. Let's see if we can get all this assembled here. Let me get some oil. ready to go. Get that on. This is the actual piston, and I had put this clamp on it just to reseat this seal, because when you stretch it over, the seal gets all stretched out. So that looks pretty good. That put on. This goes on the end of here. And I'll go get the nut and everything. Take this off. Get the nut, and I need to get some Loctite for that. I'm using some alcohol here just
this
to
is
clean
just
the
some
threads
alcohol,
before I put the Loctite on it.
this.
Make sure there's no grease or
Oil
anything
on it.
Just want to make sure that that Loctite really adheres to it well.
Loctite on there. I think I got everything.
I'm just looking at it, make sure I got everything assembled the way it's got to be, so I don't have to take this back apart again. That nut's going on snug but smooth, it's not binding, and I'm torquing it up to spec. I think it was 50 or 60 foot-pounds.
It's on.
Get everything lubricated up for putting it back into the tube.
See if I can get this assembled. Get my big crescent wrench. Flip this around.
Pretty good. Okay, looks pretty good. See if we can get a grease fitting on this and give it a try.
We'll get a new grease fitting put on here. it looks like it could use a paint job, so I'm going to scrape off all this paint that's peeling off. Just get some alcohol on it just to clean it all up.
People may be asking why I'm not spraying this, and we do have all the equipment. It's just I really don't like all the overspray, and for something small like this, it's just not worth it to me to drag all the equipment and mask everything off. So I actually prefer, in most cases, to paint it with a brush. I find it lasts longer, and I can get a better, thicker coat on. So that's why you see me doing this.
one thing I thought of when I was painting this thing is the whole reason why we had to do all this work is because this aluminum nut galled to the tube itself, which is steel. Galling means it like cold welds itself. Aluminum is a very soft steel, and when you tighten it really down tight, and over time it'll actually weld itself to the steel tube. So what I wanted to do was put something in between the threads on the aluminum and the steel tube. So what I had planned to use was just, they call it anti-seize, which is a graphite compound. You may say, well, that's not, you don't want to use that because it's going to contaminate the hydraulic oil. But the threads are going to be on the dry side of the oil. So hopefully everything is working as it should. Shouldn't be any oil come in contact with the threads. The pressure side is actually going to be on the other side of the gland nut. And I'm just going to use a small amount on it. I'm not going to use a lot. Good. Tighten it back up here. It's a nice fit. It's not too snug, but it's just a smooth fit on there.
So I'm done with the primer here. I'm going to go ahead and put some paint on it. This is Tractor Supply paint. It's not my favorite. I'm just using it to get rid of it. I just find, I personally like Rust-Oleum a lot better, but this wasn't really mixed up too well, so you see me stirring it kind of halfway through, but I ended up having to put, I think, 2 coats on in order to get everything covered.
I don't love Tractor Supply paint. It always seems like it just goes on like water. So that's what I got. So probably have to do another coat here just to get it to sink in. mixed up well. It's been laying around for years. You know what I used it on.
You're going to see I'm a little bit puzzled here because this is a male O-ring boss, and there's no swivel on it, nothing. So I'm not, I guess this is direct from Bobcat. No one changed this, but I didn't take it apart, so I was looking, thought maybe there was a swivel on the fitting, and there isn't. You'll see me trying to twist it, and ultimately you'll see I ended up having to take the cylinder off and just basically wind the cylinder onto this fitting. The other fitting is a JIC swivel, so that's easy to put on, but this one, it's odd that they didn't put a swivel on this, because it makes it difficult to put back together. So I looked around to see if I could find any swivel. There was a number 6 O-ring boss with a swivel on it, and I didn't have any. So I think I'm just going to put it back together the way I assume it got taken apart. So this is the only way I could think to do it, since there's no swivels on either end. It's basically just screw the fitting into the piston and, turn it around. You'll see what I'm going to do here. Here I'm trying to find a scheme to zip tie the hoses so they're not in the way when you lift up the arms. I tried a couple of times, you'll see this didn't work out. And we're getting back here at final assembly. There's two bolts that hold the both ends of the piston onto the actual arms for the Bobcat. That's what you see me doing here. And I go through and figure while I'm here I might as well grease it for them. So everything's secured. We're going to go ahead and give it a try. See how everything goes. You'll see that I had to work the arms back and forth a little bit because I had some air in it. You notice that the zip tie I used wasn't in the right location, so I ended up having to relocate and add a couple more just to make it so it was secure but not binding to the point that it was going to break them. I find that it was kind of slippery to get on and off this thing, so I had some non-skid, which is basically sandpaper with an adhesive back to it, and you can see me putting it on here. It didn't really stick too well. I'll tell you what I did to fix that here in a little bit.
So in order to get this sandpaper stuff to really stick down, I ended up using this stuff called, it's by DAP, it's called contact cement, and it seemed to work. We've used it on other stuff before. I just put stuff on the edges and taped it for tonight, and it looks pretty good. I mean, it looks like it's pretty stuck down. Yeah, I mean, it looks pretty good. There's none of the edges are sticking up, so we'll try it.
Well, looks like this is a success. It's not leaking. They can stay in the cab now. They don't have to get in and out to connect and reconnect the bucket. And instead of a spanner wrench now to remove the gland nut, they can just use a regular old wrench. So I think this will work out well for them.